Hey everyone, this is Amit Kumar Gautam. I am your friend, your mentor, your teacher. I again welcome you all, and beta today we will discuss a very important topic, that is the qualitative analysis of organic compound, or you can say it is practical organic chemistry. Okay, in this part what we will discuss that how to identify the different element present in any organic compound. Okay, so if it is organic compound, so obviously it must contain the carbon and hydrogen. So first we have to check for the carbon and hydrogen. Okay, so you see here, first what we do for the carbon and hydrogen, whatever the compound is given to us, we heat that compound with the cuprous oxide, that is CuO. Okay, this CuO react with the carbon, okay, and convert the carbon with the CO2. So you can see the first reaction, carbon plus 2CuO will give you carbon dioxide plus copper. And if hydrogen is there, then hydrogen also react with the cupric oxide. And what it do? It give 2 hydrogen plus CuO will give you the Cu2, will give you the H2O and Cu. So if in your compound carbon and hydrogen both are present, then after the reaction they provide you CO2 and they provide water, H2O. Okay, now how to identify this? Whatever the gas is coming out from that container, you just pass with the lime water, that is the CaOH whole twice. If CO2 is there, it react with the lime water and it will give the CaCO3, and lime water will become milky. Milkiness appeared, and if milkiness appeared, it proved that in the given compound we have the carbon, which after the reaction converted into the CO2. Okay, so what is the reaction we have here? CO2 plus CuOH whole twice will give you CaCO3, that is the white milkiness appeared, and along with that it give the H2O. CaOH whole twice is the base, CO2 is the acidic gas, acid base react together, they give one salt, CaCO3, along with the salt they also give the water molecule. And if whatever the gases or vapors are coming out from that mixture, okay, if those vapors comes in the contact with the anhydrous copper sulfate, this anhydrous copper sulfate is white in color, or you can say it is colorless in nature. But whenever the water vapors comes in the contact with it, CuSO4, it absorbs the 5 water molecule and it become hydrated CuSO4.5H2O. okay, in the common language it is also called blue vitriol. So color of this compound is blue. So if in your compound you have the hydrogen present, hydrogen react with the CuO, it convert into the H2O, and H2O will convert the colorless copper sulfate into the blue colored copper sulfate pentahydrate. Okay, in this CuSO4.5H2O, which is also called blue vitriol, 4 water molecule act as a ligand and 1 water molecule is hydrogen bonded. Okay, so you need to remember this one. In the CuSO4.5H2O, 4 water molecule behave like a ligand and 1 water molecule is hydrogen bonded. Okay beta, so this is the example where we have ionic bond also, covalent bond also, coordinate bond also, and hydrogen bond also. This CuSO4.5H2O is one of the example in which we have coordinate bond also, covalent bond also, ionic bond also, and hydrogen bond also. Okay, after that there may be some few other compounds can also be present in the organic compound, maybe like nitrogen, like sulfur, like halogen. Okay, so to identify them we perform a test which is called Lesgine test, okay, or it is also called sodium extract test. What we do here, whatever the compound is given to us, we fuse that compound with the sodium. What is the meaning of fusion? No liquid, only solid. Okay, solid compound is given to you, take the sodium and mix them and heat them. This is called fusion. It occurs generally at the very high temperature. So during the fusion what happens, sodium react with the carbon, and if nitrogen is present, that will give you the sodium cyanide. If in your compound sulfur is also there, then sodium react with the sulfur and give the sodium sulfide Na2S. If in our organic compound halogens are also there, so sodium react with the halogens also and it give the sodium halide, maybe the NaCl, maybe the NaBr, maybe the NaI. Okay, once these compounds are obtained, we mix that given remaining solid in the distilled water and we boil it. So these are the ionic compound, they dissolve in the water. The filtrate is called sodium extract. The filtrate is called sodium extract. This sodium extract filtrate we will use for the detection of nitrogen, sulfur and halogen. First, how we perform the detection test of the nitrogen. So you see now in that sodium extract we have cyanide. In that sodium extract we have cyanide. Okay, what we do, we add the FeSO4. We add the FeSO4 in that solution, ferrous sulfate in that solution. Fe plus 2 will react with the 6-cyanide. Cyanide is one of the good ligand. Okay, so when they react together, they will give the coordinate compound. So when this reaction occurs, how this reaction occurs? Fe plus 2 plus 6Cn minus will give you FeCN whole 4 minus 4, like here. Okay, then we add the concentrated H2SO4 in the solution. Concentrated H2SO4 oxidize ferrous to the ferric. Concentrated H2SO4 oxidize Fe plus 2 to the Fe plus 3. Now this Fe plus 3 will react the compound which we obtained by the first reaction. So how this reaction takes place? Fe plus 3 will react with the FeCN whole 6 minus 4 to balance this equation. What we do, whatever charge here, that become the coefficient of Fe plus 3, whatever charge Fe plus 3, that become the coefficient of FeCN whole 6 minus 4. During the reaction they combine together and they give Fe4 FeCN whole 6 thrice. This compound is called Prussian blue, and due to the formation of Prussian blue, the solution become the blue in color. If solution become blue in color after the reaction with the Fe plus 3 and FeSO4, it presents that in the given compound nitrogen is also there. Okay beta, this Prussian blue is also called Turnbull's blue. The information I would like to give you, that Van 't Hoff factor of this compound is 1. Many students they feel, if I change the direction, 1 mole of this compound Prussian blue, it gives the 7 ions. So Van 't Hoff factor is maximum up to the 7, but it is not true. Okay, this compound has the Van 't Hoff factor 1. Actually this is one coordinate bonded complex. Okay, here Fe plus 2 and Fe plus 3, Cn minus is present between the Fe plus 2 and Fe plus 3, and you know that Cn minus is the ambidentate ligand. It can donate the electron sometime to the Fe plus 2 and it can also donate the electron sometime to the Fe plus 3. Due to this charge transfer, Cn minus can donate the electron to the Fe plus 2 also and Fe plus 3 also. Due to this charge transfer, the solution become the blue in color. So if the Turnbull's blue or Prussian blue is formed during the reaction, which indicate the presence of the nitrogen. Now let's see the detection of the sulfur. Okay, what we do, sodium extract is acidified with the acetic acid. Sodium extract, in the sodium extract we add the acetic acid. After that we add the lead acetate. So in that case what happens, the sulfide present in the sodium extract that react with the Pb plus 2 and they form the PVS, which is black color in solution. Okay, which is black color precipitate. This reaction indicate the presence of the sulfur in the given organic compound. Alternatively, what we can do, we can take the nitroprusside. We can take the sodium nitroprusside solution and it will react with the sulfide. So what is the reaction? S minus 2 plus nitroprusside FeCN whole 5 NO. This time NO has the plus 1 charge. FeCN whole 5 NO bracket close minus 2 charge. They react together and they give violet color compound, which is FeCN whole 5 NCS NOS minus 4. So alternatively we can do this test also. So detection of the sulfur can be done by the either lead acetate or by the sodium nitroprusside test. If in the given organic compound both are present, nitrogen is also present, sulfur is also present, so they will react with the sodium in presence of carbon to give the sodium thiocyanate. And this sodium thiocyanate whenever react with the Fe plus 3, that give the blood red color FeCN HCN plus 2. Fe plus 3 react with the HCN minus to give the FeHCN plus 2, which is red in color, which is blood red in color. So beta, if only nitrogen is present, then they will give the blue color test, but if along with the nitrogen sulfur is also present, so they give the blood red test. Here we can write blood red in color. The given organic compound, nitrogen is also present and sulfur is also present, and if we use the excess amount of the sodium, then sodium thiocyanate, it react with the excess of the sodium. How this reaction takes place? 2Na plus NaHCN, it again provide the Na2S like here and NaCN. In this case they will give you usual test. There is no formation of blood red color. Remember student, these are the few important points. If halogen is present in our organic compound, what we do? That organic compound first acidified with the HNO3. Okay, in that HNO3 we add the silver nitrate. In that acidified solution, okay, acidification is done by the HNO3. Okay, in that acidified solution of this NaX, we add the AgNO3. If suppose Cl minus is our halogen, that Cl minus will react with the Ag plus and that give the white precipitate of AgCl. This white precipitate of AgCl is soluble in the NH4OH. Okay, if bromine minus is there, then Br minus react with the Ag plus and that will give you the pale yellow precipitate of AgBr, and this AgBr is sparingly soluble in the NH4OH. If in that given compound iodine minus is there, then iodine minus react with the Ag plus to give the AgI, which is the golden yellow color precipitate, and it is insoluble in the NH4OH. So that is how you can identify the halogen present in the given compound. Now you see what we do for the phosphorus. First, the compound in which we want to check the presence of phosphorus, that compound is heated with the sodium peroxide. With the sodium peroxide, all the phosphorus converted into the sodium phosphate. That sodium phosphate is acidified with the HNO3. Then HNO3 is the stronger acid and sodium phosphate is the salt of the weak acid. It has to be a strong conjugate base. So acid and base, they react together, and during the reaction what they give? They will give you orthophosphoric acid H3PO4. Okay, in itself it convert into the sodium nitrate. Now in this solution of the orthophosphoric acid, what we add? We add the ammonium molybdenate. Okay, what is the ammonium molybdenate? NH4 twice MoO4. NH4 twice MoO4 is the formula of the ammonium molybdenate. In the solution of H3PO4 we add the ammonium molybdenate. How the reaction takes place? 1 mole of H3PO4 plus 12 mole of ammonium molybdenate NH4 twice MoO4 plus 21 mole of HNO3. That give us 1 mole of ammonium phosphate molybdenate. That formula is the NH4 whole thrice PO4 dot 12 MoO3, which is yellow in color. It makes the solution yellow in color. Okay, and along with that it also gives the 12H2O and 21 NH4 NO3. So if this yellow color is formed, then we can prove that in the given compound phosphorus is also there. Okay beta, so these are the very small technique, or you can say very short revision of your practical organic chemistry. If you remember this one, obviously if some questions comes on the basis of this topic, you can solve very easily. Okay beta, so again we will meet in the next class. For this time, thank you and goodbye beta.